Hello students, today we are going to study about the alcohols. The alcohols are organic compounds which consist of single bond OH functional group. Now the word functional group, let's define the word functional group. So what are functional groups? Functional groups are a groups of atoms in a structure which determines the characteristic of the compound. So let's go into the iPad and draw the structure of alcohol. First, let's define what functional group is. Then let's study about the structure, draw the structures of alcohol, and also how to name the alcohol. And then we'll move on to the different chemical properties of the alcohol. So let's move on into the iPad. Now let's first of all define what functional groups are. F-U-N-C-T-I-O-N-A-L, functional groups. G-R-O-U-P, let's underline it. So functional group. So functional group is a group of G-R-O-U-P, group of atoms in a structure, S-T-R-U-C-T-U-R-E, in a structure which determines, D-E-T-E-R-M-I-N-E-S, which determines the characteristic, C-H-A-R-A-C-T-E-R-I-S-T-I-C, characteristic of the compound, C-O-M-P-O-U-N-D. So what is a functional group? Functional group is a group of atoms in a structure which determines the characteristic of the compound. So today we are focusing our attention towards the alcohol functional group. So let's write down that A-L, alcohol, H-O-L, alcohols. Now what are alcohols? So alcohols are a series of organic compounds containing the functional group single bond OH and with a general formula CnH2n plus 1, so and single bond OH. So let's write it down and learn it. So alcohols, what are alcohols? They are series of organic compounds containing the functional group single bond OH, and we also call this as hydroxyl group. We also call it as a hydroxyl group, H-Y-D-R-O-X-Y-L. So we also call it as a hydroxyl group, and it has a general formula of CnH2n plus 1 single bond OH. So this is how we write the general formula of the hydroxyl group, that is alcohols. Now the first alcohol has only one carbon in it, and it is known as methanol. So let's draw the structure and formula of, first write down the formula and then draw the structure of methanol. So how can we write down the structure? So only one carbon and CH3OH. So this is the formula of the first alcohol, and it is known as, we call it as methanol, M-E-T-H-A-N-O-L. So what we observe over here is that they all will end with the letter, we can say the suffix OL. The suffix will be OL. So all the alcohols will have a suffix of OL. So methanol, ethanol, propanol, butanol. All right. So all of them will have a suffix of OL. So if we want to draw the structure, let's draw the structure over here, C over here, and then we have H, H, H. So C3 and then O single bond H. So this is how we draw the structure of methanol. Now the next one is ethanol. So let's write it down. This is number 1. So number 2 is ethanol, ETHANOL. So here ethanol is consisting of 2 carbons, so C2H5OH. So this is ethanol. Let's draw the structure of ethanol. There are 2 carbons, so let's do that, and then H, and then again another H there, here another H, single bond O, single bond H. So this is ethanol. The third one is known as propanol. So it will have 3 carbon in it. So let's go to the next page. So let's draw the third one, that is known as propanol. So PROPANOL, and it will have a formula of C3H7 single bond OH. So if we draw the structure of propanol, let's draw the structure. There are how many carbon? 3 carbons. And then let's add the hydrogen. 1, 2, 3, 4, 5, 6 and 7 hydrogen. Then single bond O and H. So that is propanol. Let's do another one, that is butanol, and sometimes we also call it as butane 1-ol. We have isomer of it, butane 2-ol and butane 1-ol. So let's draw butane 1-ol. So what's the fourth one? Butanol. So BUTANOL. And what will be the formula? C4H9OH. All right, and then let's draw the structure of it. How many carbons are there? 4 carbons. So let's draw that, C4 carbons, and then we have hydrogen. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and 2 more, 7, 8 and 9, and O single bond H. So there is butanol. So these are the 4 examples of the alcohols. Now let's move on to study about how ethanol can be prepared. So there are 2 basic methods, through which methanol can be prepared, or ethanol can be prepared. One method is known as hydration of ethene, that is by addition reaction, and the second method that we are going to learn is by fermentation. So let's study them one by one. So first of all, let's learn about hydration of ethene. So let's write it down. Making of ethanol by hydration, HYDRATION, hydration of ethene. So ETHENE. So let's underline it. So this is preparation of ethanol by hydration of ethene, and this is the industrial method of making ethanol. Now in this method, what we do is we will take ethene. Let's write it down. We'll take ethene, 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 plus we'll take steam, STEAM, and then we will pass it through a catalyst, that is phosphoric acid. So, and it will have a temperature of 300 degrees Celsius and atmosphere of 60 atm. So let's write that down. 300 degrees Celsius and 60 atm, that is atmospheric pressure, and then phosphoric acid, H3PO4, and we will get ethanol, ETHANOL. Let's write down the equation underneath it. So ethene, we all know, C2H4. Ethene is a gas, so we can just write down that gas, plus water vapor, that is steam. So we can write down H2O, but in the bracket we can put it as gas because it's a steam. And then we know what's the condition. What we do is in this ethene and steam are compressed to 60 atmospheric pressure, and the temperature is 300 degrees Celsius, and we pass it through the catalyst, that is what we call as phosphoric 5 acid or phosphoric acid. So in the end product will be ethanol. So ethanol is, how do we write down ethanol? Let's write down ethanol. C2H5OH. So this is ethanol. So this is how we prepare ethanol by industrial method, and it involves the addition reaction. And in this what happens is steam and ethene are passed over the catalyst phosphoric acid at a temperature of 300 degrees Celsius and atmospheric pressure of 60 atm, and we get ethanol. So this is the first method of preparation of ethene. Now we will, so let's study how to prepare ethanol by fermentation. So let's first write down the spelling of fermentation. Fermentation. So what is fermentation? So fermentation over here is a process in which we can say it's an anaerobic process. That means it takes place under a condition where there is no air or oxygen available. And in this process what happens is we have yeast, and the enzymes in the yeast help to ferment the sugar like glucose. It can be obtained through many fruits and like grapevine, and even we can get it through other fruits also. So this is the way how we first of all take glucose, that is from fruit, and then we ferment it to a temperature, a very nominal, not a very high temperature. If the temperature is very high, then the process will stop. So we should keep a nominal temperature of about 37 degrees Celsius, and the enzyme in the yeast will ferment the glucose into ethanol and carbon dioxide. So ethanol is prepared by the fermentation process. So fermentation is an anaerobic process where oxygen is not involved. It's a process where oxygen is absent. So we can write it down. Fermentation is an anaerobic, that is absence of oxygen. ANAEROBIC, an aerobic process. That means in the absence of oxygen. So let's write down the equation of how ethanol is prepared by fermentation. So first of all, we'll take glucose, GLUCOSE. So what is glucose? Glucose is C6H12O6. So that is glucose. Now naturally, let's put aqueous over here, and then on the top we can put down yeast. From yeast is a fungi, microscopic organism, that is fungi. And what does it produce? It produces enzymes. So ENZY enzymes, ENZYMES enzymes, like invertase enzymes. These are the enzymes which are produced by the yeast, which anaerobically converts the glucose into ethanol. So let's write down ethanol, C2H5OH, plus carbon dioxide is also formed. So ethanol we can write AQ over here, and carbon dioxide we know is a gas. Let's balance that. That is 2 over here, and then here is again 2. So we can write down the spelling ETHANOL, and then we can write down carbon dioxide, CARBON, carbon dioxide, DIOXIDE. So if we can't see that, we'll just rub the aqueous there, and we can write down the aqueous this is not aqueous but gas, carbon dioxide gas, so we can write it there. So there we are. So the first method is by hydration of ethene, and the second method is by fermentation process. So sometimes a question is asked in IGCSE exam or CBSE exam. The question is, which method is better and why? So both the method are okay in a way, but there are some advantage and disadvantage. The advantage of fermentation is that fermentation by ethanol is made from renewable resource like glucose and coming from fruits and all. That's a renewable resource, whereas ethene is coming from a non-renewable. The origin of that is a non-renewable resource like petroleum. So that's the advantage of fermentation. Also, the process in fermentation is very the procedure or the process is a very simple and straightforward process, whereas in ethene it's more complex process. But there's a disadvantage of preparation of fermentation, preparation of ethanol by fermentation, and that disadvantage is that the product formed has to further go for. Now let's move on to some of the reactions of ethanol. So let's go to a fresh page and write it down. So reactions of ethanol, we can just the reactions, reactions, the reactions of ethanol. Ethanol. Now the first reaction of the ethanol is that the ethanol is used as a fuel, because whenever we burn ethanol, it will give a clear flame, giving out quite a lot of heat and light. So we can use it as a fuel. In a small scale, ethanol can be used as a methylated spirit. That means a small amount of ethanol is mixed with a small amount of methanol or other compounds, and therefore we can use it as a methylated spirit. We can use it as in the spirit lamps and all that are available in the labs. Then countries like Brazil and countries which produce a huge amount of cane sugar, they usually convert the ethanol produced from cane sugar into fuel, biofuel. So it's actually helpful because it reduces the use of non-renewable fuels like the petroleum products. So let's write down the equation of the ethanol when it burns in the presence of oxygen. So how do you write it down? Ethanol, ETHANOL, ethanol plus oxygen, OXYGEN, will give you carbon dioxide, DIOXIDE, plus water, because whenever we burn a fuel, it will always give you carbon dioxide and water. So let's write down the equation: C2H5OH plus O2. This is liquid, O2 is a gas, and it will give you carbon dioxide, which is a gas, plus water, H2O, which is a gas. Let's balance it. 3 over here, and then we have 3 here, and then we have 2 here. So that is balance. So again, once more, use the reaction of ethanol. It shows us that ethanol is used as it burns with a very clear flame, and it gives quite a lot of heat. So it's used as a fuel, and it's made into a methylated spirit also, METHYLATED, methylated spirit, SPIRIT. How is it made into a methylated spirit? When we add small amount of methanol with ethanol, it turns into a methylated spirit, and that we can use in spirit lamps and stoves, etc. Let's go to the next chemical reaction. So the next chemical reaction is oxidation. So let's study about oxidation. I hope it fits here. OXIDATION. Now oxidation takes place in ethanol. So if we have ethanol and we expose it to air, after some times it will have a vinegary or sour type of smell and taste, and that is known as acetic acid. In the olden days they used to call it as acetic acid. Now we call it as ethanoic acid. So that is that is vinegar, what we call CH3COOH. And if we it's formed by when we expose wine or other stuff, alcohols into with oxygen, then gradually it will turn into vinegar. But in the lab we can we can forcefully and very fastly convert it into ethanoic acid by using a very strong oxidizing agent. And that oxidizing agent that we use is acidified potassium dichromate, sorry, acidified potassium magnate, which we have to warm and add to ethanol, and nascent oxygen is produced which will oxidize it. And also what we'll observe is that the color of the potassium magnate 7 solution will turn from purple to colorless. So that tells us that the ethanol is completely oxidized to ethanoic acid. So let's write down the equation. So oxidation of ethanol. So what is the formula? Ethanol C2H5OH plus we can write down, this is nascent oxygen. This is nascent oxygen. From where does that oxygen come from? That comes from actually by the oxidizing agent that we are using. We are adding powerful oxidizing agent and warm acidified potassium magnate. And what will it give you? It will give you ethanoic acid CH3COOH plus it will give you water. So we can write that down and remember we can write down 2O over here to balance it. So where does that come from? We can write it underneath. It comes from, what are we using over here? We are using we are adding warm warm potassium 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 manganate, that is acidified potassium magnate. So let's write that. Acidified is very important. So warm acidified acidified potassium 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 manganate MANGANATE, and we can, in the bracket we can write 7. And when we add this warm acidified potassium manganate solution to it, it will oxidize ethanol into ethanoic acid and water. And the color of acidified potassium magnate will change from purple to, color will change from, I'll write it down, color COLOUR color of acidified FIED acidified potassium it won't fit over there, so we can just write it down like that. Color will change from, we can write it in the bracket over here, color will change from COLOUR, color will change from purple 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 to colorless COLOURLESS. So this is how we can write it down. So this is the oxidation process. Color will change from purple to colorless. So this is the oxidation process or the reaction when oxygen is there provided due to the strong oxidizing agent that we have, that is very powerful, we say powerful oxidizing agent, that is potassium magnate. So let's keep that in our mind. And wine and all, when we expose it to air, it will gradually become it will become ethanoic acid. So that's why we don't have to expose them to air. Now let's move on to the next reaction. The next reaction that we talk about is esterification, that is formation of an ester. So ESTERIFICATION. So let's underline that, esterification. So what is esterification? So what is esterification? Esterification is formation of sweet smelling substance which is known as ester. Whenever we react an alcohol with a carboxylic group, that is acid group, then in the presence of, that is very important, in the presence of concentrated sulfuric acid, it will give a sweet smelling substance which is known as ester. So let's write down the equation and understand it. So let's take ethanoic acid. Ethanoic acid is CH3COOH. That is ethanoic acid, that's liquid, plus an alcohol. Alcohol is ethanol, CH2C2H5OH. So this is ethanol. And not forgetting, let's write down nicely, concentrated CONC. Let's write the short form, concentrated H2SO4, and then it will get converted into an ester, CH3COO. We should be able to write down the correct formula of the ester, CH3COO, that is C2H5, plus this is a liquid, plus we have water, H2O, which is also a liquid. So this is known as ethyl, 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 NOATE, which is an ester, ESTER, ester. So remember, very important is we should always use a concentrated sulfuric acid as an catalyst over there. So this process is known as esterification. Why? Whenever we react a carboxylic group, we can just write it underneath the equation, ethanoic acid, which is a carboxylic group, CRBOXYLIC, carboxylic acid group, functional group. And then we have ethanol, ETHANOL. What is that? That's an alcohol, alcohol, and it will be converted into ethyl, ethanoate, and water. So this process is known as esterification. So this is one. These are some of the chemical reaction of the alcohols. So I hope students you have understood this portion. You have understood what function group is, and you studied about the first function group that today we focused on, that was alcohol. Next time we'll study about the carboxylic acid group, but I hope the alcohol is clear to you. Thank you for listening to my video, watching my video, and going through it with a lot of patience. And students, if you like my videos, if you want more of it, please subscribe, please share with your friends, and also you can write down some comments here, and that I would appreciate that a lot. Thank you once again, and all the best for your exams.